stress tests or strain measurements are done on bridges, and some of the modern bridges which are long span and very important bridges actually being monitored on a continuous basis. Buildings, the same thing. There are some buildings in California where we have strain sensors on the building to measure the effect of earthquakes. Aircrafts are typically tested when they are on the ground, when you are coming up with a new aircraft, when you are designing a new wing or a new fuselage and so on, and they are typically tested when they come in for maintenance. But what we want to do is to sort of build these into the structure itself, so that you start doing monitoring on a more regular basis, not necessarily on a yearly or a annual basis, which is what typically occurs now, or a semi-annual basis. Yeah.
Our strain paint is just a polymeric varnish of the sort that you would use to protect a surface, into which we have dispersed the carbon nanotubes. And once that's applied to the surface and cured, we can come along with a laser beam to excite the nanotubes that are in the film, and using an optical device we can capture and analyze the emission that those nanotubes provide, and from the spectral positions of that emission we can deduce how much deformation or strain there is in that surface without ever touching it.
Well, the laser coming from the source is actually impinged on the sample here, and we have the strain paint on it, and we actually stress the sample by rotating this particular knob here, and with this we would be able to get the perfect reading from this sample, and that shows up in the screen. The result will show up in the screen, and this is how the entire experiment has been set up.
It's a clear coating that can be painted onto any surface, so that it really doesn't affect the color of whatever the surface was to begin with. And we're measuring strain at very low levels. So we're looking at any substrate or material that would require investigation of strain at low levels before they would think that something may be a problem with it. At those very low levels, these nanotubes can sense that low level of strain, up to 1-2% strain.
The strain gauges are typically have been used for over 50 years for doing this kind of a thing, and it's time for new technology where things are done in a more with all the digital advances that we've made. This could potentially, and the 787 aircraft, which is the new Dreamliner, has some of this sensing technology being built into the material itself. And here the advantage is the material not only becomes a sensor, it can also strengthen, protect the material, the surface of the wing from corrosion, things like that. So it becomes a multifunctional material.